Welcome folks. In this video we are going to look at the introduction of acids. Now the first definition that will give acids is that an acid is any substance that forms hydrogen ion when dissolves in water. So we have hydrogen ion when dissolves in water. Then what is an ion? So an ion is a charged atom or group of atoms. Now this hydrogen ion has a positive charge, so that is what you are supposed to know. Then the other definition that we can give to acids is that acids are proton donor, which simply means that they have the ability to donate a proton. Now, away from there, we also have to look at what is the state of acids when they dissolve in water. What state are we going to have? We are going to have what we call aqueous solution. So that is the state of all acids. Then the definition for aqueous solution is a solution in which a substance is dissolved in water. So whenever we have a solute and it dissolves in water, the solution that forms will have a state of aqueous solution. Now this dissolving is chemically known as ionizing. So if what we can say, an acid is a substance that ionizes in water to produce a positive hydrogen ion. So if ionizes is breaking or is dissolving in water, then what is really meant by ionizing? So to ionize simply means to become an ion. So before the ionization of acids, we just have a normal compound. But after it dissolves in water, it is going to break into individual ions. Now, away from the ionization, we have two types of acids. So acids are in two types. So we are going to look at the strong acids here. Then on the right side, we are going to have weak acids. So what is really meant by a strong acid and a weak acid, or what is the difference between the two? So the first difference we can look at is a strong acid ionizes completely. So we have the completion, which is about 100% breaks into ions, while for weak acids they ionize partially. So that is our first difference. Then the other difference is strong acids forms what we call strong electrolytes. So an electrolyte is a substance in which electricity can flow. So for strong acids, they have the ability to conduct electricity easily compared to weak acids. So that is the second difference here. We are going to have a weak electrolytes. Then examples of strong acids, we have hydrochloric acid, the second one we have sulfuric acid, nitric acid, and we can just say most of the acids where the ion with a negative charge, if it is coming from group 7 element, then such acid is considered to be strong. Then for weak acid, we have ethanoic acid. So this is an example of a weak acid. Phosphoric acid is also an example of weak acid. Even carbonic acid is an example of that. Now, away from the two forms of acids, let's look at the generalized equation. So now what happens if this acid is put into or dissolves in water? So we just want now to make an equation from that. So the generalized equation, we are going to use this as an example. So any acid must have the hydrogen. So let me not first use this one. So we're going to use this. So whenever this acid, if it has a chemical formula of HX, the hydrogen must form a positive charge with the state of aqueous. Then the X will form a negative ion. So from this is where we're going to now look at how to ionize, how to write an ionization equation for acid. So let's begin with HCl. Right, so the first one, you begin by writing hydrogen. So the hydrogen must have a positive charge. Then the number here is 1. So if it's 1, you don't have to show 1. So you just have to write the hydrogen. Then aqueous plus the chloride must have the negative ion. Now let's move on to the second one. So the second one, we are going to look at the sulfuric acid. So we begin now, we have H2SO4. So I'm going to do it now step by step. So the first step that I'm going to do here is I'm going to remove one atom of hydrogen. So have plus aqueous plus. Then since we have removed one, we are going to have one hydrogen SO4 with a negative 1 since we only removed 1. Then the second one, we are going to take this part, we bring it to the reactant side. So we'll say HSO4 minus. So we are going to remove the second hydrogen. Plus SO4. This time we are going to have negative 2 since we have removed 2 hydrogen atoms. Now, how are we going to write the net equation? So to write the net equation, we are going to combine the two equations. So if we combine the two equations, it means that I need to look at the substance on the reactant side, which is exactly the same with any of the substance on the product side. So you can see that this is the same as this. So after identifying, what are you supposed to do? We cancel. So we cancel the substance that we have exactly on each side, so remaining with H2SO4 aqueous. Then we are going to add. We'll say hydrogen plus aqueous plus another hydrogen plus SO4 minus 2. So these two are like terms, so they can be added. So our final answer will be SO4 aqueous. So we have 1 plus 1, we have 2, H2 plus aqueous plus SO4 minus 2 for aqueous. So this is our final answer. But in a simpler way, we can just say sulfuric acid right. So you first begin write the hydrogen positive ion aqueous, then the number, that the subscript for hydrogen must be written in front of the positive ion. So that's what we are supposed to do, plus SO for minus 2 aqueous. So we can simplify it like this. We move on to now nitric acid. So the nitric acid has this chemical formula. So in this one we can see that we only have one atom of hydrogen. So we are going to have a similar case with the hydrochloric acid, so which is aqueous plus NO3 minus aqueous. So this is our equation. Now let's look at now how do we deal with the weak acids, because the examples that I've given you are for strong acids. So let's begin with ethanoic acid. Has the chemical formula CH3 COOH aqueous. So don't forget to draw a double arrow whenever you're dealing with the weak acids. So the hydrogen that we are going to remove is this hydrogen. We write hydrogen plus aqueous, then plus we are going to have CH3 COO minus aqueous. So this is our final answer. Now let's look at the last part in terms of ionization. So we are going to look at the phosphoric acid. So feel free, you can pause the video and give it a try. So even this one, we are going to use a double arrow since it's a weak acid. So I'm going to remove one hydrogen. So we have this hydrogen plus aqueous, then plus PO4 minus 1, since we only removed the one hydrogen. So this should be H2PO4 minus. Then we bring this to the left side, so we have hydrogen 2PO4 minus aqueous. We remove the second hydrogen. We are going to have this hydrogen plus C, so we only have now one hydrogen atom remaining. So PO4 to the power negative 2, since we have removed 2 atoms of hydrogen. Then let's take this to the left side. We have HPO4 minus 2 aqueous. Then we have H aqueous plus PO4 minus 3. Then can we find the the net equation? Yes, we can. So let's cancel. So I can cancel this one, I cancel this one, then I cancel this, I cancel this. So from this side we can see that we only have this part. So is what I'm going to write here. So H3PO4 aqueous. Then the other thingy, I need to add all these 3 hydrogen ions. So since there are 3, I'll put 3 H plus aqueous. Then plus this part here, which is PO4 3 minus. So this is our final answer. Then the other things that you can look under this short discussion is you need to look at the properties of acids, like they have sour taste. Then apart from sour taste, you need to look at chemical properties, how do they behave if they react with, let's say, an acid, a base and a metal. So we'll consider this video as our first part and in our series in acids, the topic of acids, bases and salts. So that's it for this video. Thanks for watching.